Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Redeen, who has just completed the course Linux Basics, and he'll be giving us a presentation on that. So first of all, we'd want to see his code base running on the real robot, and then after that we'll get into the details about his implementation detail and what he did, the logic behind what he did. So let me now hand over the platform to him so he can begin his presentation. All right, whenever you're ready, Redeen.
So, hello everyone. My name is Redeen, and I start with telling the overview of my presentation. First things first, I will explain how I created the script files, and then demonstrate the robot, then explain the codes. So there's two ways to creating the files. First one is using touch, then last touch, then the name of the files. But importantly, you have to put the .bash to make it work. And the second one is by going to inside a Python package and right click new file, same thing, name of the file, then that bash. And now I'll move on to sorry. After you create the file, you have to give them permission to be executed using chmod. I'll show you how to do that. So yeah, LA, and as you can see here, the one I created, which is obstacle avoider, have green lights. And also, as you can see here, the RW have X, but the terminal.py doesn't have it, which is look like that. So yeah, so to make it executable, you have to do the chmod, chmod and X, something like that. And yeah, and I'll move to demonstration now. Is that okay?
Yes, that's fine. It's let's go.
So first one, you have to to connect the to the robot, you have to source the simulation first by doing the source simulation. Then also to connect to the robot, I need to launch the ROS2 launch, but instead of using Gazebo, I'll use the real robot.
Okay.
So I think that's connected. Oh my god. Now the RB is popped up and it seems it's connected. So yeah, then I'll go to the next one, which is running the robot interference and to the new terminal. So by doing that, I have to copy this, copy, and robot interface. Okay, running this command, and I have to wait for 5 seconds and see if it's ready. Now it's ready, so I can move on to my control logic, and I have to open the new terminal. And obstacle avoider.
Okay.
Let's see if it. As you can see, the parameter set successfully, and it's showing all the parameters in meters, and it's also showing which one is free and which one is not.
Right.
The first one is going straight because
Alright, Redeen.
the distance took to go there.
Okay, I think
And
I lost
it
you
also
a bit.
says the
Yeah,
right.
I think I lost you a bit. Okay, just you can continue. It's okay.
Okay, I see. So yeah, it seems to be working. And now it's because it says 011, it's turning right because the right side have to decide. I mean the program have to decide where to go, and yeah, I think it's going okay. And so can I move to the robotic statistic, or do you have, hello?
Yes, you can move to that.
Okay. So I'm moving to the robot statistics now, into the new terminal as well, and run the robot statistic.
All right.
And here, so yeah, the robot seems to be working. It's following the algorithm that I want to, that I implemented. So yeah, and for the robot statistics, is showing the direction and position of the robot. As you can see, it says direction SSS and the distance it travels. So also it shows the position and orientation.
Obstacles, which is good. Now I want you to go through the whole obstacle avoidance script, right? So I want you to be explaining bit by bit what it's doing and how you manage to have it avoid obstacles, right?
So I'm gonna expand this. Can I black this the robot, or
just make sure you stop it from moving around so that you can then switch to the code editor.
Is this okay with that, or?
Yeah, it's fine. As long as you stop the robot, it's okay. Or maybe you can use full screen so that we can see it much more clearly. Yes.
Maybe I zoom in then, like that. How's that?
Yes, much better.
So for the obstacle avoider, first thing, the important part here is the shebang, because it's not gonna work if we don't have that.
Yes.
And also for because this one, the source that robot is using the other bash file to be clear, so I don't need to do the function inside the obstacle avoider. So yeah, and the echo just print out these messages, and these two lines are just setting the velocity in angular and linear velocity to 0, and also I set the threshold to 0.3. Also for this one, this is my own function, which just makes the negative value into positive, but I didn't use this, but I just put it here just to explain it because it's still there somewhere. I just commented it out.
All right. So, in which cases did you have to use it? Like,
I use it cause some. Wait, I'll show, this one. Okay.
Yeah.
So I use this because the time to move sometimes becomes negative. So it's picking the robot interface node disconnected. So that's why I put the absolute function to make it positive even if it's negative.
Okay.
So
all right.
That keeps the connection connected. So
okay. So when you're saying when you got negative values, your robot interface node would terminate. Is that?
Not really. It's giving me errors.
Oh,
Sorry
okay.
for my term.
Right.
It's just giving me error.
Okay. So you wanted to do
I don't want to see that error, so that's why I put that.
Yeah, I think it's good because you minimize the number of things you have to keep track of in case something goes wrong, right? So you want to know you're debugging the right things.
Yeah, but the thing is, when I put that, it's making more error because the robot, if it's supposed to stop when it's negative, right? But the function makes it move forward. So in the gazebo, it goes out of bounds, and that's terminated everything.
Okay. All right.
So I remove it, and instead of doing that, I change it to just if else statement. So yeah, I just make it, if it's negative, then don't do anything, just stop. Then if else, then just go forward. That's what I did for that part.
All right.
So and it seems to be all working, so I'm happy with that. So yeah, I'll go to my I'll go back to my while loop.
Sure, let's go.
So for my while loop, so they want me to do get all the 5 scan ranges. So these lines do that, and what this line does is it's just the output of get scan left range input output of that save into LL range, yeah, variables. So yeah.
And
So
what?
next one.
So
Sorry?
this is just for. Are you processing the data that you're getting, or it's just for
Yeah.
printing out? Okay.
I just for printing out.
Okay.
But I can use the LR range if I want to do something else. Like here,
Oh, all
I
right.
use it as to be negative or positive
Mm-hmm.
to decide whether to go left or right.
All right, all right. So you're
So
assigning to a
yeah,
variable so that you can use it
yeah,
later.
yeah. That's
Mm-hmm.
what I
Okay.
did. And I also do the same thing here, but this line of code just makes the yeah. I use this variable as well. Some of them to make it if it's either if the threshold is uh if the threshold is larger than, for example, the FF range, then it's positive, means the front is free,
Mm-hmm.
and same as the others.
Okay, okay. Can you also explain to me how you dealt with the fact that you had those function return floating point numbers, right? How did you deal with that?
Yeah, can you repeat that? Sorry.
So your functions, right? Your getter functions, when they returned floating point numbers, how did you deal with that in your script?
I don't get what you
Okay, so
can you explain in
numbers
other words?
numbers with
Yeah.
decimal points, right? So for
Yeah.
example, yes, how did you deal with numbers with decimal points? So let's say 1 point something something point 00 or point 0.01. How did you deal with that fact? So if your laser scan data was not giving you an integer, how did you handle that case?
Um, I'm sorry, I don't get your question, but
Okay, so let's look at FR range, for example, right? So you call the
okay.
get scan front left ray, right?
Yeah.
And that getter function, when it does not return an integer and you want to process it, you want to process LL range somewhere down in your script, in your obstacle avoidance script, how did you deal with the fact that it is not an integer, it is not integral?
I think the FR range, they are float, right? So
Yes, that's what I'm
they,
asking. Um,
oh, okay.
yes.
There-
How did you deal with the fact that they are floats, not
I thought you
integers?
want me like to I thought initially there are integers, then you asking me how do I convert it to
Oh,
float. So
no.
so it's just you want me to tell it's just a float.
Yeah, I want you to explain
Okay.
how you did it, because base scripts, they like to work with integers, right? Unless you do something. The
Uh,
something is what I want to know. What did you do?
so we just make it float. So yeah, I think I'm moving forward here.
Okay,
Is that
let me phrase the question another way, right? What is
okay?
the purpose of BC? Like in where you're processing like front right tree free, right?
Mm.
And you echo the range data, but you do some comparison of front R range with the threshold value, right? And then you put pipe BC stroke L, right? What is the
Mm.
purpose of that? Do you understand what that is doing? It's your code, right?
Yeah,
So what?
is it this one makes it one and or zero? Just make it positive or negative. False or is that you're asking?
Well, you kind of are trying to answer my question, but it's not what I was expecting. But can you try again? BC, why do you need that? Or L, alright, let's just talk about stroke L. Why do you need that in that function itself?
Uh, I'm not sure, but
Alright, let's go on to the next bit, and then
I
we
just know
we
that
can.
it's converted to true or false or one or zero.
Oh, okay, alright. I highly recommend you do try to find more information about that. Okay, let's go to the next bit, and then you can explain some more.
So for the control algorithm, what I did is if it says here 000 means everything is black.
Mm-hmm.
So inside if statement, there's another if statement which decide whether to go left or right. So this one says LL range. If LL range is greater than are arranged, which these two are just left or right. So if it's big, if left or bigger, then turn left, and and else just turn right.
Okay. All right.
And then sleep, then wait for the robot to do the rotating, then stop.
How did you choose the sleep time? Can you explain that?
For this one, I just do it multiple times, because sometimes when I put 1.6, which is the same as the simple patrol, it got if it's stuck in the corner. If it's stuck here, for example, it's just rotating, I think 30 degrees, and when it's rotate, for example, going right, it will go here. So around here, then it's just keep rotating left and right if I put 0.6 or below. So, and I'm not sure 0.7, haven't tested that. But when I use 1.8, when even if it's at the edge, it's working now. I mean, it's keep moving forward to the different direction. That's why I put 1.0.
So you had to try different values to figure out which one works best.
Yeah.
Okay, all right.
Yeah, that's what I did.
Okay.
So, yeah, I think I already. Now for this one, wait, is this for This one is if it says front is free, and front left and front right are not free, then just move forward. And here is just calculate the distance and the time it takes. And here I already explained this part, so yeah.
All right. Any other bits that you wanna speak about?
They're all pretty much the same. I think that's all. I think so. Because else it's just move forward. For else to finish it, just move forward. If 111 is free, then move forward.
All right. So, how many laser scan indexes are you checking when your robot is moving, right? To ensure that it doesn't collide, how many indexes are you checking? Are you checking only the front one, or is there any other? Go ahead.
I'm also checking. I'm checking if everything is open, then just go forward.
Okay. Everything of how many? Of 3, of 6, of 8?
Three.
Okay. Because I
So,
understand in this one you also have got indexes for the back, right? So you can have back left, back right, back. So that's why I'm asking which ones. Yes.
yeah, just the front left, front and front right.
Okay.
Just the trio. Yeah.
Okay.
Just one, and that's it.
All right. So we spoke about the obstacle avoidance script, right? That's the main one. So, and you also did
next. The robot statistic and robot function.
So in the last 3 minutes, can you just run through that one? So
for the robot function, same thing. We need the shebangs, and this one I just copied it from the simple robot. Here the getter file and the setter file as well is the same, but the difference is just the WK and the.
And what does that AWK do? What's the purpose?
It isn't just the one is just for printing and printing the data from the get scan write range, array range, something like that.
You have to think about it in conjunction with the print $4. You have to think of it that way.
I haven't looked at that, so
yeah. Okay. Because why I'm asking these things, if you're given scripts that you can use to help you carry out another project, right? It is very important for you to understand what you're tagging and what it does. That's why I'm asking, do you understand the way it works? But in this case, I think you must also check to find out and get detailed understanding, so that when you have to edit this, at some point you will know, okay, that if I change this is what happens, right?
Okay.
Because right now you're getting exactly what you want, but the important bit is to understand what it's doing, so that you can you can leverage it further for any other things that you may want to do in the future. But yeah, okay, that's all right for that.
I look at this a little bit. Is the like they said it's just like printing the data from this, right? From the, for example, the get scan write range is just making it printed.
Yeah. Yeah,
Something
well,
like
I could give the
Yeah,
details, but I
yeah.
think that is the bit you're supposed to do. So, all right,
Yeah.
let's go to the next. Any other scripts that you want to explain? Oh,
Yeah, this one, the robot statistic.
yeah.
Yeah, so yeah, for robot statistics, same thing for obstacle avoider. I put the source that robot function and the shebang as well, and print it. And inside my while loop, same thing, saving the data from into the variable of distance, and because it's a float, I put this line to make it three decimals, and for the O direction, I put S because it's the string. So yeah, and it's basically everything is the same. It's just the printing convention is different.
All right, all right. Thank you very much, Redeen. Thank you so much for your presentation. So, I think you hang around and then we'll have a conversation with some of you. All right, everyone. This was Redeen's presentation, and congratulations to him. Would like to thank him for coming and showcasing his work, and we encourage all those of you who would want to do the same to do that, book a session, and you can come and showcase your work for whichever course that you can get a certificate on. So until next time,